This tiny SQL quirk can silently break your queries and cost you hours of debugging. But this video should help you spot the issue early on, understand it, and even prevent it from happening at all. Take a look at this simple table with names: John, Mark, Null, and Diana. And what do you think would be a result of the following query? Here is a chance for you to hit a pause, because in 2 seconds I'll reveal the result. So, the result is Mark and Diana. You might be wondering, wait a second, Null doesn't seem to be equal to John, so why is it not included in the result set? And this is absolutely fine logic, because in most of the programming languages this is exactly what we should expect. Because, for example, here, take a look at the Python code snippet. And in this snippet we do the same thing. We define a list of names where one value is none, and then we filter it for the values where entry isn't equal to John. And in the result, as you can see, we have Mark, none, and Diana. So this empty value is included in the result set. And here is where it can get a bit dangerous and where it can cost you hours of debugging. So it's easy to spot the issue in such a tiny table of names, but just imagine that you are cleaning up a dirty dataset of millions of rows, and say this table includes company records, and you apply a filter like this one to get rid of test accounts because you don't want them. Looks like a simple, harmless condition. But if we have values for this account name column, then you're dropping more data than you expect. And the condition silently skips nulls, and that can lead to missing data, misleading results, and hours of discovering why in the final result we have less columns than we expect. Or even worse, you might not notice the issue at all. Alright, so the root cause for such behavior in SQL is a 3-valued logic. So in SQL, any comparison can result in the 3 ways. The first one, it can be true. The second one, it can be false. And the third one, the comparison can result in null, which means basically unknown. We don't know what the value is. And this is exactly the reason why we have such behavior here. So when you write something like this, select everything from people where name is not equal John. SQL evaluates each row's name like this. If the value is any string not equal to John, then the condition is true and the row is kept. If the value is John, then the condition is false and the row is discarded. But if name is null, the comparison becomes null not equal to John, and the result of this comparison is not false, it's null, and therefore SQL discards it. The last case can seem a bit counterintuitive, because it feels like it should pass through, but it doesn't, because where condition keeps only entries where the result is equal to true. At this point, let's try to understand why does it even work this way. Why isn't null not equal to value just true? The reason is SQL treats null as unknown, not an actual value. Try to think about it this way. You don't know the name, it's null. So can you say for sure that the name isn't John? No, you can't, because maybe it is, maybe it isn't, it's just unknown. So the comparison null not equal to John results in null, meaning we can't say. And if you think about this logic a little bit, you can get a feeling that it's kind of actually pretty nice, and that's what we would expect like in the beginning. Because would I want the rows in the result where I'm not sure if it's John or not John? I guess not. The next question we are gonna answer is how to deal with it, how to deal with such cases and how to achieve the desired result. There are 3 ways how to handle it properly, depending on what you want essentially. The first option is to exclude only exact matches but keep nulls. and the condition would look like something like this, where name is null or name not equal to John. Another option is to exclude both nulls and John, but this way we do it explicitly, which is obviously better because your intention is clear here, and the expression looks like this, where name is not null and name not John. The third option and the most concise one is to normalize nulls using COALESCE. Basically the condition would look like this, and we are saying here that if the name is null, then essentially replace it with an empty string and compare empty string to John. With such conditions, null rows will be kept in the result set. Here is a visual example for you to maybe remember this three-valued logic better. Think of it like checking IDs at the door of the club. You ask, is your name not John? If someone says, hey, I'm Mark, you let them in. If someone says, I'm John, unfortunately you can't let them in, these are the rules. And if someone says, I won't tell you my name, can you just assume that they are not John? Not really, therefore you can't let them in. And this is essentially how SQL behaves. With that, let's conclude. So next time you write not equal in SQL, remember it silently ignores nulls. That's three-valued logic in action. Dealing with weird results of the filtering, again, check for nulls. Interested in more content about SQL, data and software engineering, subscribe to the channel, I would be really happy to have you here. With that, thanks for watching and happy coding!